You guys had 0 views of my previous videos. The other classes have like 12 and 13 each, but you guys had 0. So I assume that I'm doing such a good job right now that none of you need to watch the video. That's the assumption I'm making. Yeah. So, can anybody tell me, and please understand this, I am looking for the definition of a prism. Do not give me an example of a prism. Here is what I mean. I want the definition of a good-looking math teacher. Don't say Mr. Myers, because I'm an example of a good-looking math teacher. You understand? I want the definition of a prism. Can any of you do that? You all know what a prism looks like. Can you define it? And don't feel bad if you cannot. 20 years I've been teaching this course. Almost never do I get a definition of a prism. I get 27 examples of what prisms are. Jacqueline.
Also,
did you just Google it?
yes.
Yes, go ahead.
A solid geometric figure whose two end faces are similar, equal, or parallel rectangular figures, and whose sides are
Perpendicular would be my guess.
No.
Polygons.
Yes, that.
Okay. Yes, because that's what happens when you Google stuff. You guys go to the first link, and it's got a whole bunch of words you don't know, and you write them down, and you say, I got it. Kind of like when I asked you how long a meter was. Y'all read the first sentence in the Wikipedia entry, right? One of these years, I'm going to adjust the Wikipedia entry right when I ask you how long a meter is. Because you can, of course, edit Wikipedia. And I'm going to change it to say something crazy, right? Like how many steps from Louis XVI's bathroom to the guillotine. Something like that. And hopefully nobody will catch on Wikipedia long enough for somebody to Google it, check on Wikipedia, and tell me that's what a meter is. It will be fun for me. But I probably won't. So, what Jacqueline just said as she Googled the definition of a prism is this. It's a solid geometric shape that has two faces that are the same. So, now I'm going to do give you an example of a prism. This is a prism. Okay? Yes, exactly. It's a cube. It is a prism because the faces that are across from each other, so the top and bottom, the left and right, or the front and back, are the same. Now in a cube, they're always the same. So the cube is a really bad example to show you what a prism is. Because a cube is all the same. But this is not. This is also a prism because the top and the bottom are exactly the same, right? It's a rectangle. And they are separated by what? The sides. And the sides are all what shape? They are what shape? A rectangle. A prism is simply any three-dimensional shape that has two sides that are the same. No. Got to have two. Because if you got more, it's not a prism. It's got a different name.
Oh, it has to have two sides.
Two sides that are the same that are separated by rectangles.
But it can have other sides that are the same size. It can have these.
Yes. Like this. Doesn't matter where you start. They're the same.
Like with the, this is the front and back are the same. The sides are the same.
Yes. Okay. So the prism is a 3D figure with two, I don't want to say similar, two congruent, which means they're exactly the same, two congruent faces. And they are separated by rectangles. Now, That's a definition. We can all get our minds around that, yes? Now, the problem with geometry that gives you guys a hassle is we use the same words to describe a whole bunch of things. And those words have different meanings than they have in English. Okay? So, what this is saying, and I'm going to use a geometry word, the base is the same as its opposite. And I ran out of room there. Normally, what does the word base mean? The bottom. Okay? But it also means the point we start from, right? If you're playing baseball, you start at home base, right? It's not the bottom. A baseball diamond's flat. Everybody understand? So you need to get into your head, base, you all know that base means bottom. If I stand up, what is my base? My feet, yes? But if I do a cartwheel, at some point my base is my hands, yes? Everybody understand? If you only think of base as the bottom. Base is also the point from which you start. Everybody cool? So, the way I am holding this textbook right now, this is the base, right? Everyone agree? Because it's on the bottom. But it's also the point I start from. Because this rectangle is repeated up here. So the base and its opposite are the same. Everybody with me? What if I turn it this way? Can you still call this the base? You could. Why? Because I'm repeating that shape, aren't I? But is it now the base of the prism? You would say this was the base if we were talking about the bottom. But does this rectangle work as the base from where we start? Yeah, it does, because doesn't this rectangle repeat up here? Is everybody with me? Base doesn't necessarily mean the bottom. It is the shape from which we start. Everyone cool? All right, so now that we've talked about that, let's draw a couple of them. The easiest one to draw is, of course, the cube. What do we know about a cube? All four sides are what? The same. If this is the side I can see, that's the side I'm starting from, yes? So is it the base? Yes. And I would repeat that shape straight backwards until I have made another square at the back. Everybody understand? Now, the way I've drawn that, you could argue that the base for the bottom is under there, correct? But since it's a cube, it doesn't matter because they're all always the same. But we could also have a rectangle. And that is going to repeat backwards to make a rectangular prism. Everybody good? And I can do that with any shape. Okay? If I made it, and you don't need to draw this, I just want to show you. If I made an octagon, a stop sign, and I repeated it backwards, now I have an octagonal prism because the front is the same as the back. But technically, the base is the octagon because that's the shape I started with. Does everybody understand that? Okay, now we get to the hardest one of all. Is this a prism?
No.
Pretend it's not fat in the middle like your math teacher. Pretend it's straight all the way down. Is this a prism? What's the definition of a prism? A 3D figure with two congruent faces separated by a rectangle, right? Okay. What shape is, I almost didn't close it and dumped coffee all over myself. What shape is that? No, that's a circle. What shape is that? Are they the same? What's in the middle of it? A rectangle. Right? Because if I roll this, circle, circle, rectangle. Everybody with me? But we give the circle prism a special name. What? The other thing you said when you meant to say circle. A cylinder. And the cylinder is the important one because it is the best for explaining base. All right? Here's my cylinder, agreed? It is lying sideways on the ground. What would you say is the base? The whole thing is the cylinder. The circle is the base because that's the shape that repeats. Agreed? Even though it's not on the bottom. Now, if I make this a tower, is the base shape now also the bottom? Everybody understand? All right. Now we move on to the one that most of you probably, I won't say most, some of you probably have not worked with pyramids. When I say pyramid, what do we all immediately think of? Egypt. We've all seen them. Many cultures use pyramids. The Aztecs had pyramids. The Mayans had pyramids. Tons of cultures have pyramids. How do they differ from a prism? Because again, I don't want an example. I want a definition. Right. It's still a 3D figure, right? A 3D figure. And it still starts from a single shape, right? But then what happens to it? Does that shape repeat? The shape repeats, but what changes? The size. It shrinks or expands from that. Everybody understand? It starts with a single shape, and actually it only gets smaller. A single shape that repeats in a reducing fashion to what? When does a pyramid end? Till a point. I don't care. Say what you want. Whatever you need to know. If I have a square on the bottom, it's going to shrink and make a pyramid. Because at every level of that pyramid, if I cut a line in it, I'm going to make a square, aren't I? But all those squares are going to be smaller than the bottom one. What if I start with a rectangle? Then I'm going to get the same thing. A rectangle all the way up. What if I start with an octagon? Same thing. Can I do this with a circle? Yeah, what do I get? I start with a circle, and it goes up and shrinks to a point. And what do I get? A cone. It gets a special name as well, because circles are a pain in the butt, right? Because of pi. So cylinders and cones get their own special names. But the point is, both of these start from one shape that we can define, and then they start repeating off in another direction. Everybody good? Before we go any further, right here, I want you to write again, the base is the starting shape. It is not necessarily the bottom. Highlight that. Put a star around it. Put a Mrs. Bad Crumble cloud around it. Underline it. I don't care. Somehow get this into your head. The base is not necessarily the bottom. It is the shape that you start from. Everybody good? Nathan.
How do you determine what this shape and stuff looks like?
Well,
Like with the pyramid, so you could cut it up.
okay.
Rectangle.
If I had this pyramid, don't write this down. That's the pyramid, right? The bottom of it is a square, right? If I cut it in half, right there, I'm going to get just the top of the pyramid, right?
It's still in the shape.
That is still a square. It's just smaller.
Oh, it's like the layers are
Yes.
the same.
The base is the starting layer, if that helps you.
Okay. Like it doesn't work.
If I were to cut it this way, it wouldn't work because it's not the same. Okay? Now, the other problem, the other word we use in math all the time when we're doing geometry is height. What does height mean in real life? What's my height? Where does it go from? My feet to my head, right? Base where? Starting point to the end point. That is key. Come on, Miss Lloyd.
Sorry to interrupt. You wouldn't have an
Nope.
no. Okay, thank you.
Everybody understands that my height goes from my feet to my head, yes? In a straight line, agreed? Okay. So its base is at the bottom. What if I lie down? Now what's my base? My back is on the bottom. Would you measure my height from my ass to the front of my belly? No, why not? Because that's not height, right? The other word you have to be aware of is this, height. And height is the straight line, perpendicular line. Perpendicular means 90 degrees from the base. And the base is not necessarily the bottom. And I will give you an example of this. Go back to our pyramid here. If this is a pyramid in real life, you want to call this the base, yes? Because it's on the bottom. So the height must be from the bottom straight up to the top. Agreed? Well, pyramids, for example, there's a pyramid at the very famous art museum in France called the Louvre. That pyramid looks like this. Sorry, I drew it badly. I drew it very badly. Damn it, it's hard to draw it.
Some of them face upside.
That's the point I'm trying to make. The pyramid there is upside down.
The big one.
The big one's on top, and it's balancing on its point, like this. So what's the base? Is it that point that's at the bottom?
Yeah. Wait, no.
No, it's still that square. Everybody with me? So get the word base and height out of your head to mean bottom to top. It means the point you start from and the direction that shape repeats. Is everybody good? Okay. Let's start with a real easy one that you've all already done from the 9th grade. Cereal box. Math O's. Front of the cereal box. How does that will repeat this way to the back of the cereal box, correct? Do I have a prism? Yes. Now, the way I have drawn this prism, what was the shape I started with? It was mathos, yes? And I repeated that shape backwards. Yeah? Which means the way I drew it, where is the base? The front of the box. So what is the height? Front of the box to the back of the box, because that's the direction I repeated. Everybody understand? That's the math formula. Now in reality, you guys all want to say, this is the base and this is the height, don't you? Because the cereal box stands up in your cupboard like that. Everybody with me? Does it matter? Not really. So we're all cool, right? So we are going to do the surface area of that box. What is that box really? It's a prism. And what is a prism made of? A repeating shape. So, I could say that shape repeats that way, couldn't I? So what shape is that? It's a rectangle, right? How do I find the area of that rectangle? Length times width, right? Who decides which is length and width? You do. But you were taught in like grade 3 that width is the shorter side, weren't you? So where are you going to put the W on this green rectangle? You're going to put it here? Where are you going to put the L? Right there. That's a problem though, because you want to call this the height, don't you? Because the cereal box is standing up and down. But does it matter? No. So this green rectangle, length times width. Well, here's your 3 measurements. What number is going in for W? 24. What number is going in for L? 40. What's left? 8. So the way we've drawn this, there's my H. Agreed? So how many of these green rectangles are in my cereal box? 2. Why? Why are there 2 of the green rectangle? Because there's one on the back. So 2 times LW will get me the front and the back, won't it? Is that the whole surface area? No, I got to add more to that, don't I? So is there another rectangle on here? Where? The sides. Okay, there's the blue one. Agreed? And that blue one, as a rectangle, it's length times width, isn't it? Right? If it was only this blue rectangle, we'd use length and width. But we can't use length and width, can we? So we have to use what there for the blue one? H and L, right? How many of them are there? There's 2 H times L. That's the blue rectangle. Agreed? And what's left? There's going to be 2 of what? The top and bottom. And what letters are they? W plus, or not plus, idiot head, times H. And that's the yellow. Now that's what's actually happening, yes? If you draw it, is it possible to do this wrong? Not really, right? But here's what most of you are going to do. You're going to go to your data booklet, which you already have, and that tells you that the surface area, I don't want to write it there, that the surface area of a prism is 2 LW plus HL plus WH. I can't remember the exact order, but that's what it's going to tell you. And you're going to punch that into your calculator, and you're going to screw it up because what math is happening right there? And what math is happening right there? Addition. when you punch this into your calculator, a bunch of you are going to go times, 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 or you're going to go plus, 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 plus. And then when you hit equals at the end, your calculator is going to give you an answer. And all of you are going to do what? Write it down, whether it's right or not. Everybody understand? That's why it took so long to explain how the formula works, rather than just show you the formula. Everybody good? So great, go ahead. Tell me what this answer is now. You can either use the drawings we've done, or you can try and get it with the formula. Go. Yes, Sajo. Yeah, it's this, right? Every formula we have comes from building it by pieces. Yes, Jenna, go ahead. That's something totally different. Yeah, that's you're thinking of volume, which we will be doing, but not until after we understand surface area.
Yeah. Is there a simpler formula?
Nope. So it's either 24 times 40 plus 8 times 40 plus 24 times 8, which is 960 plus 640 plus 192 times 2, which is 192 times 2, which is 386, I think. And that is 1986. Centimeters what? Why is it squared? Because, no. Why is it squared? Because I am counting centimeters this way and centimeters this way, which gives me this distance, which is a centimeter, 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 a square centimeter. 2 dimensions, area. Now, I got to check and make sure those numbers are right. Are they? Has somebody done this yet? 24 times 40 is 960. Oh, it's 9. I forgot to multiply by 2. Yeah. It's 1920. Now, did I multiply that one by 2? Yes. And did I multiply that one by 2? 384. Then you got to add it up. Sorry, should have brought out my calculator, but I didn't. So I get 2,944. Now, that's doing it the long way. Did anybody try to do it this way all at one shot with their calculator? And did you get it? So everyone's cool, right? Either way, you're good. Everybody's cool with a prism? A prism is always this. You can always find a prism by adding up all the sides. Please notice on your formula sheet, you only have a formula for a rectangle prism, don't you?
Yeah.
Is a cube a rectangle prism? Yes. So you can do it. Nathan, what would you like to say?
Would you say centimeters cubed or centimeters
Squared, because it's area. Holy crap, this is the wrong page for you people. This is the honors page. Is this what yours says?
Yeah.
Okay. Cross out rectangle. Cross out 48. It's a square pyramid with the base dimensions of 32. So that means our base, the shape we start from, is a square, yes? How big is it? 32 by 32. Agreed? Okay. And then I get these triangles. Yes? It's a pyramid. Everybody cool? Everyone agree? All right. So if I was going to find the surface area of this, I need that surface, don't I? What shape is that? That's a square. Plus, how many of these other sides are there? What shape is that? And how many of them are there? 3? 4.
Oh, wait, yeah. There's 4. I think
Agreed? It's a square and 4 triangles. That's all it is, right? Because if I unfold this thing, I get a square and 4 triangles, don't I? Everyone agrees? Okay. What's the formula for the surface area of a square? Yeah, it's length times width, but since they're the same, it would be side squared, correct? Everyone agree? Okay. Plus 4 triangles. What's the formula for the area of a triangle? Does anyone remember? It's on your sheet. Right, it's the base times the height divided by 2, yeah? Now here's that base and height problem, isn't it? If I draw the triangle this way, it's a red line and a green line. Where's the base? What's the height? Green line, agreed? But what if I turn that triangle over? Now what's the base? Still the red line. Agreed? Okay. What if I give you this type of triangle? Purple, peach. Where's the height? The peach one. Agreed? Okay. Because we started this, we said was the bottom. Now we get into trouble. What if I give you this shape? Now, where do I draw the red line for the base? Where could I draw it? Right here? So where would the height be? Height is always 90 degrees from the base, isn't it? Everybody cool with that? Now, what if I turn this triangle over and I draw it this way? Could you say that's the base? But then the height would be straight up to there, right? That doesn't really work, does it? So where would you say the base is in this green one? You would say that's the base and that's the height.
Why is that the base?
Because when you look at it the simplest way, without turning it, if this was a mountain, this is how you would count the height, wouldn't it? And the base is always 90 degrees away from the height. 90 degrees. If I turn that triangle, I am allowed to turn where I make the base and the height.
So it's a square on the bottom.
Sure. Everybody cool with that? Okay, now let's look at this situation. What do you see there and there? 4 and 2. Where's the 4? Numerator or denominator? Numerator. Where's the 2? Which means I have this fraction, don't I? What is 4 divided by 2? 2. So a formula I could write here is s squared plus 2bh, right? Everyone cool? Now this is weird though, because what do you want s to stand for? Square? Okay. So that's here and here. Agreed? But what part of the pyramid is that and that? Those are the sides of the base, aren't they? So when we write a formula for this, the guys that invented the formula called this b squared. And they called this side b because that's the base of the triangle. Everyone okay? Plus 2 base. Is that the same?
Yeah.
That line right there is this line right here, yeah? So it's the base of the pyramid and it's the base of the triangle, yeah? The height of the triangle is right here, isn't it? Which means it would be up the side of the pyramid, wouldn't it? Is that the height of the pyramid? It's not, is it? Prab, why is it not the height of the pyramid? Where should height go from? 90 degrees from the base. So if this is my base, height needs to go right up there, doesn't it? So that's not the height, is it? So we have to give it a new name. And the name that we give that pink line, is slant height. Which you guys need to know is the measurement up the side of any pyramid. So base we can leave there, right? But I can't say height, because height would be right in the middle. So what do I have to put here instead of height? What do we, slant height, an S. So surface area equals that. Everybody cool? Now let's put in our numbers. Do I know how big the B is? What is it? 32 squared. Plus 2, what's the base? 32. And what did I give you? If I wrote the word slant right there, what number would I put right here? 65. But if slant wasn't written there, do I know this? No. But I know this is 65, right? So I have this triangle, 65. How far is this? Half, which is what? 16. And then what would I use to find the third side? The thing you were taught in grade 6. Not cubed.
No.
Right. You may need to do Pythagoras, which you people know as a squared plus b squared equals c squared, to get a slant. Please put a Mrs. Bad Crumble cloud around that. If you don't have a slant, you may have to do Pythagoras. We are going to put slant there. It's supposed to say slant. I copied and pasted the wrong one into your guys' book, apparently. So then I punch that into my calculator and I get an answer. And you're all capable of doing that, right? Nathan.
For this higher, why did we change the 4 to a 2 again?
Because 4 divided by 2 is 2.
Oh,
It just simplifies. I want to show you where the formulas come from. So if you ever need to do something with this and don't have a formula sheet, you're able to do it.
So you understand where you're supposed to start?
Yep. Yes. In this question, because I told you it was. If I didn't say slant height, if it was just height, then you got to do this move. Right? Pythagoras gets me slant height. If you don't know it, you get it from there. Everybody cool? All right. Let's try the next. Oh, what's the answer there? You guys punch into your calc. Tell me what you get.
What was
Those are the sides and the hypotenuse. That's A, that's B, and that's C. Jacqueline. Pardon me? Why did I switch? Oh, right. Because in a square, we want to call this a side, right? In a square, it's not a length or a width because they're exactly the same thing, so we always call it a side. But that doesn't work in a prism or a pyramid because this line right here is the side of the square, but it's also the base of the pyramid. So to make the formula look easier, so we can just write B and B, we make it the same letter. The problem with formulas is you guys all want to jump right to the formula and go. But when I give this formula, if I don't explain this, too many of you say this is 32 times 32, and then you square that answer, right? Because you think it's base squared, squared. But it's not. So let's, by the way, I know all of you keep looking at the clock. I am not giving you any work tonight. So do not worry, because you have a quiz tomorrow. No, this is not on the quiz. Conversions. What is the answer? Somebody punch that in, because that sounds about right to me. Let's check. On. 32 squared plus 2 times 32 times 65. 5,184. You just punch in what you see. Now that you've seen everything that could possibly happen to you, everything, we're going to use it all in this question. And we're going to work through it nice and slowly. A cone, how does a cone start? Starts with a circle. We're only going to draw half a circle and then put dotted on this side. And we squish it down because we're drawing in 2 dimensions, right? You know that's a circle. And then where does a cone go? Up like that. Agreed? Yeah. So there's my cone. What is a cone made of? Well, it starts with this circle, yes? What's the area of a circle? It's a circle plus something, right? And we know the circle is pi r squared. Yeah? We know that from grade 7 or whenever we were taught that, right? And the r is this distance. How far is it? 15. Everybody cool? Now the rest of the cone is this shape. It's a piece of a circle, right? Well, if it's a piece of the circle and I need an area, I must need pi and radius, right? Right? Okay. If it was a whole circle, it's pi times r, r squared, right? But this isn't a whole circle, is it? Right? It's an r, but it's not a whole circle. So what this area works out to is it's plus this shape, this piece of a circle, and that works out to pi r and then the slant. Where in this drawing would the slant live? Down the side. So here is my slant. Read the question. Do I know it? The first question you have to ask yourself is, do I know the slant? And Satjot says, yes or no? No. What do I know? The height is 22. So what shape What angle is right here because I went base height? That's a 90 degree, right? So I have this triangle. 15, 22. How do I find my slant? I remember that Pythagoras gets me my slant. So I do slant equals 22 squared, then what? Plus 15 squared, and what do I have to do to that whole answer when I'm doing Pythagoras? Because I've been doing Pythagoras for 5 years. What do I have to do at the end of Pythagoras every time? This will get me s squared, but I don't want s squared. What do I want? S. So I have to square root that. And when you do that, what answer do you get? You get 26 exactly? Bunch of decimals, right? Okay. How many decimals do I like? 2? Okay. But decimals are a pain in the butt, aren't they? Because in grade 10, we're going to do something with pi. What is pi? 3.14. Does it end there? How far does it go? Forever and ever and ever and ever. 3.141596. Forever and ever and ever and ever and ever, right? Up until this year, your teachers always said, make pi what? 3.14. Since the first day he or she taught you about pi, she said, or he said, make it 3.14, didn't they? For the rest of math, you are never going to do that again. You are going to leave pi as pi. So this question becomes pi times 15 squared plus pi times 15. Now, when you did this work, you got another crazy decimal, didn't you? Right? I don't want you to write that crazy decimal.
How did we get 26?
I'm about to show you. The same way you would get 26 all the time, Nathan, by doing Pythagoras. 22, 22, 22, 22 squared plus 15 squared got me 709. And then you got to square root that. Except when you square root it, you get that hideous decimal, don't you? We're trying to get rid of decimals. So we're not going to write that crazy decimal. In grade 10 and further, we are going to write this. For you guys, you're used to giving us 26.09 or whatever the heck it is, right? I want you to write this. That is the square root of 709. Everybody with me? So our S is the square root of 709. So what would I write here? Square root of 709. Everybody cool? Because that's what it is, right?
After you get the 709, what would you do?
You would square root it up till this year. From now on, I don't want you to, unless it's perfect. So if you square root it and you don't get a decimal, then you can put that number there. Now, what is 15 squared? You can do it on your calculator. It's 15 times 15. It is. So this is 225 pi. And this is 15 square root 709. And then write pi again. That is the way your math class from now on will want to see answers with pi. Some of you will never understand this year because it's the first time you've seen it. Some of you need to do the decimals. That's okay. Is everybody with me? If you have to, go ahead and punch this into your calculator. Do not use 3.14. Use the pi button because every one of your calculators has it. Every one of your calculators has it. So observe this answer. Everybody sees it right there, yes? Watch. Square root 709 equals. So there is it was 26.63, yeah? So watch. If I do pi times 15 squared plus 15 times the square root of 709, right, times pi again. Oh, crap, I didn't want the pi under the square root. So, all of you see right here, I have pi r squared, yes, plus pi r slant. Agreed? Exactly what I've written right here, yes? If I hit equals, it gives me an answer. If I punch that in, it gives me that same answer. I did lie. You have a quiz tomorrow. I want you to try one question tonight. The last question on page 29. You have one question of homework. We'll talk about it again tomorrow after the quiz.
I did not get that. I think I'm just not reading things.
At my house, 2 trees, like from the roof just fell over. Like completely. Like it snapped and everything. I wish there was no. I wish there was like no.
Bro, my sister didn't have to go to work. Her school yeah, there's no power at the school. She doesn't have to go to work.
So